Welcome to our lesson on the pH scale. The pH scale is a fundamental concept in chemistry that helps us measure and understand the acidity and alkalinity of different substances. Throughout this video, we'll explore what pH means, how the scale works, and why it matters in everyday life and scientific applications. So what exactly is pH? The letters pH stand for power of hydrogen. pH is a measure of the concentration of hydrogen ions, represented as H+, in a solution. The more hydrogen ions present in a solution, the more acidic it is. Conversely, fewer hydrogen ions mean the solution is more alkaline or basic. This simple measurement helps us understand the chemical properties of liquids all around us. The pH scale ranges from 0 to 14. This numerical scale provides a standardized way to measure how acidic or alkaline any solution is. What makes this scale particularly interesting is that it's logarithmic, which means each number represents a tenfold change in acidity or alkalinity. This compact scale allows us to measure everything from battery acid to household bleach using just 15 numbers. The pH scale is divided into three main categories. Solutions with a pH between 0 and 6 are considered acidic and contain more hydrogen ions. A pH of exactly 7 is neutral, representing a perfect balance. Pure water is the most common example of a neutral substance. Solutions with a pH between 8 and 14 are alkaline or basic, containing fewer hydrogen ions. Understanding these three categories helps us classify and predict the behavior of different substances. Here's where the pH scale gets fascinating. It's a logarithmic scale, which means each whole number change represents a tenfold difference in acidity or alkalinity. For example, a solution with a pH of 4 is 10 times more acidic than a solution with a pH of 5. Similarly, a pH of 3 is 100 times more acidic than a pH of 5. This logarithmic nature allows the scale to represent enormous differences in hydrogen ion concentration in a compact, manageable format. Let's look at some everyday acidic substances. Lemon juice has a pH of about 2, making it quite acidic and giving it that sour, tangy taste. Vinegar comes in at around pH 3, which is why it's used in pickling and cleaning. Tomato juice has a pH of approximately 4, while black coffee sits at about pH 5. These common substances help us understand what different levels of acidity mean in practical terms. Moving to neutral and alkaline substances, pure water has a pH of exactly 7, making it perfectly neutral. Seawater is slightly alkaline at pH 8, which is important for marine ecosystems. Soap solutions typically have a pH around 10, which helps them clean effectively by breaking down oils and dirt. Household bleach is strongly alkaline at pH 13, making it a powerful cleaning and disinfecting agent. These examples show the range of substances we encounter daily. Understanding pH is crucial for many reasons. In biology, pH is essential for all life processes. Enzymes in our bodies only function properly within specific pH ranges, and even small changes can affect our health. In environmental science, pH is critical for water quality and the survival of aquatic organisms. In industry and chemistry, pH plays a vital role in manufacturing, agriculture, and chemical reactions. Mastering pH concepts opens doors to understanding countless natural and industrial processes around us.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.